Losses by a policyholder are normal with mean 20,000, standard deviation 4,500. Policy covers losses subject to a deductible 15,000. Calculate the 95th percentile of losses that exceed the deductible. So we will start by finding z-score of the deductible, and it will become clear why we need that. So let x be the loss, and to find z-score of the deductible, we use our basic formula. Z is equal to x minus nu over sigma, and we want the z-score when the loss equals the deductible. So 15,000 is the deductible. Mean is 20,000. Standard deviation is 4,500. That comes out to be negative 1.11, and we want the probability x greater than equal to deductible, and that will be equal to probability z greater than equal to negative 1.11, because that's the z-score corresponding to 15,000 loss. So that's equal to probability z is less than equal to 1.11, so that's 0.8665, and so probability x is less than 15,000 will be 1 minus the probability greater than equal to 15,000 equals 1 minus 0.8665 equals 0.1335. So we have the following picture. We have the losses here, and we have the probability in the upper part. So when the losses are less than 15,000, the probability of that happening is 0.1335. Well, let's increase the font here. And here it's 15. Okay. So, and when the losses exceed deductible, the probability of that part is 0.8665, as we found here. And now we need the 95th percentile of the losses that exceed deductible. So now this is the portion on the right side of this 15,000, which are the losses that exceed deductible. And we want to see what the corresponding percentile of the losses will be. So these are losses exceeding deductibles. So if you take 95% of that, you get 0.95 times 0.8665. So that will give you the 95th percentile of the losses that exceed, so 95th percentile in this portion, but we want the corresponding 95th percentile of the losses. So you add this 0.1335, because this 0.8665 starts after a probability of 0.1335. So we have 0.1335, and then we add on 95th percent of this part, and that will give us 0.9567, which is the cumulative probability of the losses that corresponds to 95th percentile of losses that exceed deductible. So z, from the table, we want to see what z value corresponds to this cumulative probability, 0.9567. So let's look at the table. Okay. 0.9567. So we don't find that. We find 0.9564. That's 1.71. And then 0.9573. That's 1.72. So we do interpolation on these, and that ends up giving us 0.3. So that means Z is equal to 1.713 corresponds to this cumulative probability of 0.9567. And so what we are saying is that the 95th percentile of losses exceeding deductible is the same as the 95.76 percentile of all losses. So if you take the cumulative probability of 0.9567, you see its Z value, and if you find a loss value corresponding to that, that will give us the 95th percentile of losses exceeding deductible. So the loss value corresponding to this Z value is again found by our basic formula. Now we substitute Z equals 1.713 and find X. And X comes out to be 27708. And we don't have this choice, but if we look at choice B, so we have 27708, and this one rounds to 27700. Because they are rounding all choices to the nearest 100. So it rounds to 27,700 to the nearest 100. That's choice B.